So, hello everyone, and welcome back to the good stuff we have been doing. I am excited to share with you the regular season problems from the 2026 MIT Integration B exams, and they are filled with a lot of cool integrals. Although I particularly feel this year is not as interesting as it was last year, where you had a lot of definite integrals to deal with, but they are still fine integrals. So let's deal with them. So the first one here, we have to take the sum. So you have an integral over a particular sum, and if you look at this sum does seem to resemble something like this, because we know that e to the x is the sum as k runs from 0 to infinity of x to the k over k factorial. Right? So now this is not those series where you'll be told that x is less than 1 for it to work. This one, there's a formula for e square, there's a formula for e cube, because this series is absolutely convergent. It doesn't matter what x equal. So now for our case now, it may not look like they equal, but we can transform this x here. Like we have x to the a plus b equals to x to the a times x to the a power times x to the b power. So using that, you would obtain the integral from 0 to 2026, and then you have the sum as k runs from 0 to infinity of x to the 2026k, then you have times x to the 2025, all divided by k factorial. Now here, this does not depend on k, because this sum only deals with k, so we can actually pull this out of the sum, and you will get the integral from 0 to infinity, from 0 to 2026 of x to the 2025, and then you get the sum as k runs from 0 to infinity of x to the 2026k, all divided by k factorial. And if you look, of course, we are forgetting our dx. Now if you look closely now, you will notice that this sum resembles e, except that in this case we replace x by x to the 2026k. So no, just x to the 2026, yes, because if you take it, e to the x to the 2026 would equal just the sum as k runs from 0 to infinity of x to the 2026k over k factorial. So we could write this as e to the x to the 2026, and good things can happen here. You would obtain the integral from 0 to 2026 x to the 2025, and then you have e times e to the power of what? X to the 2026. Then you have a dx. Then next up, you could take u to be x to the 2026, and you notice that du would be 2026 multiplied by x to the 2025 dx, which means that this x to the 2025 and dx combined together. So x to the 2025 dx is equals to du divided by 2026. And what happened to the limit of integration? Observe here that when x equals 0, u would be 0. So when x is 2026, u would be 2025 to the power of 2026. When x is 2026, u will be 2026 to the power of 2026. So we can write this as let me see. Okay, we are running out of space here, so let me just take this out. So essentially now we could write this continuously as 1 over 2026 times the integral from 0 to 2026 to the power of 2026 times what? E to the x, e to the u du. So that would be e to the u divided by 2026, and here u runs from 0 to 2026 to the power of 2026. So that would be e to the 0 is 1. So keep in mind, so you have e to the power of 2026 to the power of 2026 minus 1 divided by 2026. So, and that is our answer, which is the correct answer also. So that number 1 is done. What about the second integral? okay, let's look. So here we have integral where the limit of integration is from 0 to log of 34. Very weird number, but the form of the denominator should, we can split this. You can write this as the integral from 0 to log of 34 of 2 dx plus the integral from 0 to log of 34 of what? 1 over 2 e to the x minus 1 dx. Okay, and then finally, you have the integral from 0 to log of 34 of 1 over 3 e to the x minus 1 dx. Now we're going to start from the first one and see what happens. So for the first integral here, this is basically 2x. So you have 2x, and you're going to take the limit from 0 to log of 34, and that would be, this is for the first integral I1. So that would be twice to log of 34. Okay, so that's for I1. So I2, on the other hand, is integral from 0 to log of 34, 1 over 2 e to the x minus 1 dx. So now, here you can make a substitution though. Let u be e to the x. Then we know that we know that x is equals to log u. So dx would be 1 over u du. So that part is settled out. What about the limit of integration? Well, let's go up here and see. If you take x, if you take x to be 0, u would be 1. So you have the integral. So I2 would be from 1. So, but now if you take u to be log of 34, u would be 34. So you have 1 to 34 of what? You have 1 over 2 u minus 1 times du over u. So you have the integral from 1 to 34 of 1 over u 2u minus 1, and this calls for some partial fraction decomposition, which is not be too hard for. I think this should be, let's keep doing it vertically, so that we can get enough space for I3. Yeah, this should not be too hard for us, because if you notice here, 1 over u 2u minus 1 is 1 over, it's going to be, let's say 2u minus 1 minus u. Okay, so that would not work. What about 2u? Okay, so what about 2u? Then you have 2u minus 1 over u. Okay, not 2u, rather, it's going to be just 2. So let's say we have just 2 here. And then, so if we do this, what works? Notice that this will become 2u at this side minus 2u minus 1, which is going to be 1 over u 2u minus 1. So we have found the partial fraction decomposition. So this integral over here would become this, to become the integral from 1 to 34 of what? 1 over 2 divided by what? 2 divided by 2u minus 1 du. Then you have minus the integral from 1 to 34, 1 over u du. So the first one here, if you want to evaluate this first case, if you take u to be 2u minus 1, du would be 2 du. Sorry, if you take t, then dt would be 2 du. So this will be the integral from, and if so this will be integral from, this will be the logarithm of 2u minus 1, and as we take from 1 to 34 minus this one will be the logarithm of u as we take from 1 to 34. So in both cases, when u equals 1, they vanish. So we only need to deal with the case of logarithm of 3 times 34. So 2 times 34, this is 8, and this is 6. So this is 8. 68 minus 1, that is 67. So we have logarithm of 67 minus logarithm of 34. Okay, so keep that in mind. So that is for I2. So let's come back to, so I2 is logarithm of 67 minus logarithm of 34. What about I sub 3? I sub 3 is literally the same thing. This is the integral from 1 to 34 of, but this one I think you have 3u minus 1. You have to do, okay, if you take u, wait, okay, this is it. If you take u to be to the x, the same thing happens, only that you get 3u minus 1. So you have to worry about the integral of 1 over u, and then you have 3u minus 1. So I think the partial fraction we did before should work. Let's say you have 3 here, and then you have 3u minus 1 over u. If you do that, you have 3u minus 1, so it should work. So du. So you have the integral from 1 to 34 of 3, you have 3u minus 1 minus the integral from 1 to 34 of 1 over u du, of course, du. So if you handle this correctly, you should have logarithm of 3u minus 1 from 1 to 34 minus logarithm of u from 1 to 34. So that should give you log of 34 is 3 times 34 rather. 34 times 3, that is 12, 2 carry 1, 3 times 3, 9, plus 1, 10. So you have 102, right? Yes, 12. So you have, so you subtract 1, so you have logarithm of 101 minus logarithm of 34. So now we can collect our results. I think we have obtained logarithm of 34 twice here. Remember that first I1 contained twice log of 34. Now this I2 contained log of 34. I3 contained log of 34. So I think this log of 34 and this log of 34 would cancel out with this log of 34 because everything here is a plus sign. So we're not expecting the sign change anytime soon, or we're not even expecting the sign change. So literally this integral I here would equal what's first log here? Log 67. So you have log of 67, then and then what again? Log of 101 plus log of 101. And then what again? Let's see if there's any cancellation. For I1 we don't have to, it's just basically 2 log of 34, and then for I2 log 67 minus log 34, I3 log 101 minus log of 34. So they cancel out. So you have 101 times 67. So what does that equal? So this is getting a bit confusing, but let's see. Okay, so 67 times 101. So 101 times 67. So you have a 7, 0, and then 7, and then 6, 0, and then 6. So you have 6, 7, 6, 7. So the answer would be logarithm of 6767. Let's check. Don't make any mistake. The answer in the book is supposed to be logarithm of 6767 divided by 2. So, but let's see if we made a mistake. Okay, yeah. This does not vanish at 1 because at 1 this becomes log 2. So we are going to subtract this from log 2. So we're going to have to subtract log 2. Okay, so that gives us the logarithm of 6767 divided by 2, which is the correct official solution provided. So now let's look at number 3 here. Very interesting problem. I've already done it, but we're still going to feature it here in our video. So I really enjoy this problem. Though it may look simple, but it's actually interesting. Now, first of all, we have to do the first integral, which is going to be the integral from 0 to half of what? Cos of pi x dx minus, we'll take pi and we'll do the second integral. Now, for the second integral, we have to expand 1 over 4 minus x squared times 5 over 4 minus x squared. So this will be 5 over 20, and then this will be minus x squared over 4, and then this is minus s squared over 5s squared over 4, and then plus x to the fourth. So this is 5 over 20 minus 6x squared over 4, and then plus x to the fourth. So that would be pi times the integral from 0 to half of 5 over 20, then minus 3 halves, 3 over 2x squared, and then plus x to the fourth dx. So now it remains for us to, this case, this is equals to sine of pi x divided by pi, and we're computing from 0 to half, minus pi times the integral from 0 to half of, no, if you compute this one, don't need to even waste our time this. If you compute this one here, you will get, yeah, this is 5 over 20 is essentially going to be 1 over 4, right? Yes, 5 here 1, 5 here 4. So you have 1 over 4x minus 1 over 2x to the third power, right? Because you get the 3 at the bottom to cancel out. So this one is plus x to the fifth over 5, and everything evaluated from 0 to half. So if you take sine of pi over 2 is 1, so this is 1 over pi, and then minus this is pi times what? Here is if everything goes to 0 as 0, so you plug in half, you get 1 over 8, minus you plug in 1/3, so you get 8 times 2, that's 64, right? 1/3 is you get 1 over 8 times 4 times 8 is 8 times 2 is 16. Yes, 16. 1 over 16, and then plus 1 over 5 times what? 5 times 32. So let's combine the like terms. So if you do the math, you should get 1 over pi minus pi over 10. I've already solved this problem before, so I won't fill in more details. Just check this playlist. I gave a very detailed solution. But then I don't know if this I'm seeing strange numbers here. That is a problem. But I know I got 1 over 10 here. But let me see. Okay, 5 over. Okay, this is not 20. This is supposed to be 16. It's supposed to be 5 over 16. This is a 5 over 16x. So that is supposed to be 32. So this is supposed to be 5 over 32. Yeah. Okay, let me just check here. Yeah, if you just go to the math, everything you're supposed to get 1 over pi minus pi over 10. So let's solve all the problems. And this is the nested integral case, and this one is I think it's the simplest among them. Though it looks scary, but don't allow this problem to fool you. First of all, you start with this first integral. The integral from 0 to 1 of x dx is going to be x squared over 2 from 0 to 1, which is 1 over 2. So in this case here is 1 over 2. So you have to now deal with this one, which is integral from 0 to 1 over 2 of x dx, which is x squared over 2 from 0 to 1 over 2. So which is going to be 1 over 4 times 2, it's 1 over 8. So this is 1 over 8. This is 1 over 8. So the last integral now will be integral from 0 to 1 over 8 of x dx, which is x squared over 2 from 0 to 1 over 8, so which is 1 over 2 times 1 over 2 to the power of 3 squared. So that is 6. That is 1 over 2 to the 7 power, which should be 1 over 128. So all the upper limit here equals 1 over 128. What about the lower limit? Well, we're dealing with the, I think it should be the same thing. Why should it be different? Okay, let's just see. We're dealing with the integral from 0 to 1 of x dx. So that would be just x squared over 2 from 0 to 1, which is 1/2. So 1 over 2. So we're not dealing with 1 over 2 to 1. We're dealing with the integral from 1 over 2 to 1. Okay, no wonder it's not going to be the same thing, because this one is now yes, no wonder it's not going to be the same thing. So we're doing 1 over 2 to 1 for this case. So we're doing the first one here. Let me use a different color for this part. We're done with the first one here. You get 1 over 2. So I'm doing integral 1 over 2 to 1 to. So we're trying to evaluate the second part here now. So that would be 1 over 2 to 1 of x dx. So that would be x squared over 2 from 1 over 2 to 1. So which is that 1 over 2 minus 1 over 2 squared over 2, which is half minus 4 times 2, 1 over 8. So we can multiply by 4. So that is 3 over 8, right? So that should be giving us 3 divided by 8. I hope we are correct, because if you make any mistake here, it's going to be brutal. So half is 1/4. Half times half, 1/4 times half is 1/8. So 1/2 minus 1/8. So we multiply both side and bottom by 4. You get 4 minus 1, that is 3. So that is 3 over 8. So you have, so now we have to do the integral from 3 over 8 to 1 of x dx. So that should give us x squared over 2 from 3/8 to 1. So that should give us x squared over no wait, so you have 1, that is to give us half minus 3 over 8 squared divided by 2. I think I may need my calculator from this one. So you have a 9 over 64. So 9 divided by 128, right? Yeah, 9 divided by 128. So you have 1 over 2 minus 9 divided by 128. So I need to multiply top and bottom here by 64. So that will get 128 here. So which means that 64 subtract 9, I'm going to get 4 out is going to be 60 minus 5. So it's going to be 55, right? Let me check calculator. So I'm getting 55 over 128, even with my calculator. So I'm getting 55 divided by 128. So now we have the lower limit as 55 over 128. Now since this integral is positive, you should expect the answer to be negative. So we're going to evaluate finally that the final answer should be like the integral from 55 to 128 to 1 over 128 of x dx. So that would be x squared over 2 from 55 over 128 to 1 over 128. So that would be equals to 1 over 128 squared times 2 minus 55 squared over 128 squared times 2. So we should be seeing something like 1 minus 55 times 1 plus 55 divided by 128 squared times 2. A lot of things will cancel out here because this will be negative 54 times 56 all divided by 128 squared times 2. So let's check. So you have negative 54 times 56 divided by 128 squared times 2. So you have negative 189 over 2048. Let me even check the official solution. This is a very weird answer. Very weird answer. I'm checking if it is correct. Okay, and funny enough, it is correct though. Look at it here. You can see with this is yeah. Funny enough, it is correct. I thought I was doing nonsense with this calculation because so many numbers here. I'm very bad at even if it's 7 times 3, find it difficult. But that is what you do when you do a lot of abstract math. All this calculation math, you just get tired of it. But you should know that even at MIT exam, if you leave your answer this way, they will still mark it for you because they don't really care if you know how to round it to the. I don't even think they will even be offended if you leave your answer this way. I don't think anybody there will be offended if you leave your answer this way. Although, why would you do this? If you have time, you just leave it this way. So there's nobody that will do this. If you still have time on your clock and you just leave it this way, I think you should be drug tested or something. But this one now, let's see, how do we even talk about this one? Where's my mouse? Yeah, what's happening? Okay. Okay, now for this one now, how do we worry about ourselves here? Well, first of all, just go get a glass of water. I'll go and take water, but we need to do this in partial fraction because I don't see. Of course, you can do some trick here. You can take 4s, you can write 4s squared minus 1, write it as maybe 3x squared plus x squared minus 1. And when you divide by s squared minus 1, you have 3x squared over maybe x squared and x squared minus 1, and then plus x squared minus 1. All divided by, of course, I know this is a denominator. All divided by x squared minus 1. I think we can this cancel out, and then you get this cancel out. You get a 3 divided by x squared minus 1 plus 1 over x squared. I think. Are you sure? Wait. Wait. Let's multiply and see. Take this and multiply this. You get 3x squared minus, take this, multiply this, you get x. Okay, this is a plus, you get s squared minus 1 divided by s squared minus 1. Okay, we cracked it. So we can now we can now write this as 3 x minus 1 and then x plus 1 and then write plus 1 over x squared. Let's get a glass of water. I'm done this. Give me a minute. All right, so I'm back. So how do we even continue? Okay, this is partial fraction. So you get I think 1 over x minus 1 and then x plus 1 of course should be 1 over x minus 1 plus 1 over x plus 1. If you take it there, you get, okay, there should be a minus here. So you have an x plus 1 here minus x minus 1 here. So if you divide, you get x minus 1 and x plus 1, so that you get it 2. So we should divide by half. So this is going to be a 3 halves 1 over x minus 1 plus 1 over x plus 1 plus 1 over x squared. So once you succeed in partial fraction, I don't think there's anything remained for us, because this is an indefinite integral. So if you take this integral, everything here should equal the integral of all of this, and this last one is going to be negative 1 over x. This one is going to be log of x plus 1, and this one here is going to be log of x minus 1. So what is there? Nothing again. This is simple, so you can continue from there. Now this one here, okay, problem 6. What we should do here is to multiply top and bottom by this, obviously. That's the first thing that we should do. We don't have anything better. Then we'll do x to the power of 1/3, and then at the bottom you get 27 times x to the power of 1 plus 1/3, and then minus 1 dx. So you get x to the 1/3, and then you divide by 27 x to the power of 4/3 minus 1. I think something can happen here, because if you take u to be x to the power of 4/3, then the u would be 4/3 and x to the power of 1/3. So x to the power of 1/3 dx, x to the power of 1/3 dx, which is what we have here, is going to be 3/4 du. So we come down, and then you will enjoy, we will have to write this as 3/4 times the integral of du over 27u minus 1. This is a logarithm, so if you take u to be 27u minus 1, so du, so the t will be 27 du, which means that du will be the t divided by 27. So you still have 3/4 times 1 over 27 integral of dt over t, and 3 here is 1, 3 here is 9, right? So and that would be 1 over 9 times 4. 9 times 4 should be 36 here. So logarithm of t plus c, so which is going to be, I think, 1 over 36 times logarithm of 27u minus 1 plus c, and then you can take the u back, and then you get the whole thing. Now for this case here, this is weird though. How do we do this one now? You have an s squared. The bottom is always going to be the issue. When you look at the bottom, we will try and see what we can do at the bottom part here. So how do we handle the bottom? We can factor out x, right? Yes, we can factor out x at the bottom. So we have square root of x squared plus x square root 2. So you can factor out, you have x, so you have an x plus square, no, this is square root x plus square root of x. And what is the connection between this and the top? Is there a connection? Well, if you do this, this is something as square root of x times square root of x plus square root of x, and maybe something can happen. What about, okay, let's just plug it and see whether something can happen. You just keep trying, maybe something can happen. So let's say you get integral of 2 square root of x plus 1 divided by, so you have square root x, and then you have a square root of x plus square root x dx. Now, okay, let's just group the top. So let's just say this is the integral of 1 over square root of x plus square root x, and then you have this as 2 square root of x plus 1 over square root of x. So I think something can happen here. So we could have this as dx, of course. This is the integral of 1 over square root of x plus square root of x. Then you will have 2 plus 1 over square root of x dx. I think we can factor out the 2. I see a pattern here. You can get 2 1 over square root of x plus square root of x. Then you have a 1 plus 1 over 2 square root of x. Or okay, this is the pattern here. They want you to notice that if you take u to be x plus square root of x, then the u would be 1 plus 1 over 2 square root of x times dx. So essentially you are doing this as twice the integral of 1 over square root of u times du. So the pattern is now clear. So therefore this will be okay. You just write it as for the integral of 1 over 2 square root of u du. So this is just going to be 4 square root of square root of u plus c, because if you take the derivative of square root of u, you get 1 over 2 square root of u, multiply by 4, you get 2 square root of u. So basically you have the answer is supposed to be 4. Square root of u is square root of square root of x plus square root of x. So square root of x plus square root of x. So I think that dx, I think that if you have a very good imagination, you could probably have solved this without going through this step. Because if you look at, I think this exam, they want it to be super fast. So they want you to like do it in good time. So if you probably take this, let's say you take u to be square root of x plus square root of x. If you take derivative, you will have 1 over 2 square root of x plus square root of x. They have to differentiate this part, so that will give you a 1 at the top plus 1 over 2 square root of x. I think from there you can now simplify everything, because this will then become 2 square root of x plus 1 over 2 times what over 4 times square root of x square root of x plus square root of x. So I think this is the fastest way, because you can realize that this 4 is the same thing as multiplying by 4 here. So you can now realize that sometimes you just have to just take a term in this integral and take derivative. Maybe something can happen. So, but that is why we love math. It's full of so many possibilities. Now, of course, I don't even need to say it. You already know what to do here. You just multiply top and bottom by e to the negative 2x. It doesn't even matter if that is the correct thing to do. You just do it. That is why we are humans. Once you see this, I don't think anybody can resist the temptation of multiplying top and bottom by e to the power of 2x. So you will get e to the x, e to the power of 2x divided by, for problem 8, I mean, divided by e to the 2x, and then times e to the 2x minus e to the negative 2x times e to the 2x dx. So that gives you e to the 3x, and the bottom part you get e to the 4x, and then minus 1, right? How do we now handle this part? This seems something like dx. This seems like something like we should probably take, because if you notice this minus 1, you want to see like u square minus 1. This can be equal u minus 1 and then u plus 1. So maybe here you could just take u to be e to the 2x. Yeah, I think that can do, because du would be 2e to the 2x dx. So okay, yes, we can write the top as this. Write the top as e to the x Should I write it like that? This is problematic. Because so many possibilities. Is it to take u as e to the 2x or to take u as e to the x? Let's explore the possibilities. If you take u as e to the 2x, derivative, this becomes u squared minus 1, but then the derivative would be then we will need the square root of u. Let me show you what I mean. You will have e to the x times e to the 2x, right, dx, all divided by e to the 2x all squared minus 1. So if you take the substitution I provided earlier, you will get a half times integral of, now e to the x becomes square root of u. So you have a square root of u all divided by, so here you have a u squared minus 1 du. So but this case now, I think we still need to take u to be t squared, so that u squared will be t to the 4 minus 1. So we still need to do as a substitution, but let's say we just take u to be e to the x. Okay, let's just say we follow this path. Let's just say we take u to be e to the x. Then notice that over here you would have to get u to the 4th power minus 1, and then du would be e to the x dx. So but then you would also have e to the 2x times e to the x dx at the top, but then at the bottom you have an e to the x to the 4th power minus 1. So if when all this is now, notice that now is e to the 2x will now be u squared. So you then have this is going to equal e to the u squared over u to the 4th minus 1 du, which is better by far. Why is better by far? Well, because we don't have to do any substitution again, and it does not involve radicals. So all we need to do now is to look for partial fraction decomposition, and how do we even handle that part? Well, we could subtract, we could write this as the integral of u squared minus 1 plus 1 all divided by u to the 4th minus 1 du. So let's continue our mission. So what's next? Well, we could write this as integral of u squared minus 1 over u to the 4th minus 1 du plus the integral of 1 over u to the 4th minus 1 du. I think this one is the only one that's going to give us a little bit of issue. But this other one is going to be integral of 1 over u squared plus 1 du, which is just going to be tan inverse of u. So we're going to do this part here, 1 over u to the 4 minus 1. Partial fraction can do that for us. Let's see. This again would be still a pain. I don't think there's any merit to this approach. So let me see. What if you take t to be, okay, let me say you would deal with this integral originally. Then here you have integral of u squared all divided by u to the 4th minus 1 du. Then what if we take u to be 1 minus x over 1 plus x, u to the 4th minus 1, u to the 4 minus 1 is going to be this, so it's going to be 1 minus x to the 4th minus x to the 4th power minus 1 plus x to the 4th power I think this is going to be x cubed plus x or something or so. At the bottom you get a trying to avoid partial fractions here, but we don't have time, so let's just do partial fractions. So let's just say this is going to equal some. I think I have done this integral before, though I have to check my book to see. I've worked on it, but partial fraction, I was thinking I was going to do another method here, but okay, let's just say this is going to be integral of a over u minus 1 du plus b, the integral of b over u plus 1 du, then the integral of cu plus d over u squared plus 1 du. Okay, so we look for a, b, and c. Now, usually in this case here, a should equal to 1/4, and b should be negative 1/4, and then c should equal 0, and then d is equals to half. So you have 1/4 of the integral of 1 over u minus 1 plus integral of 1 over u plus 1, and then you get plus half of the integral of 1 over u squared plus 1. So you get 1/4 of the logarithm of u minus 1. No, minus here, and u plus 1. Then plus half of the logarithm of u. No, half times tan inverse of u. So you get half. This will be tan inverse of u plus the hyperbolic tan inverse of u as well. So when u equal e to the x, I believe so. So that goes to show for this part. Now for number 9, I hope we have not skipped that part. Integral for number 9. So let's see. Okay, number 9. Okay, number 9 is a whole integral. Okay, this is going to be some heavy trigonometry. This is probably going to consume the most of our time. So let's still deal with it. It says we should find the integral from 0 to pi of sine x, sine 2x, sine 3x, sine 4x, and usually when you get the integral from a to b of the absolute value of x over x dx, this is basically a sine function, like, because this is going to equal to the integral of a to b of 1 if dx, if x is positive, and it's going to be integral from a to b of negative 1 dx if x is less than 0, because of the absolute value of x definition. Wait, if x is positive, it's going to be 1, and then if x is negative, yes, it's going to be this. So that is that. Now, how do we handle this out? Well, we have to simplify. Let's call it f of x. Let's say f of x is sine x. The best way to factor, that is what we want to know, when it is positive or negative. So in this case, actually the best way is to factor. So let's see how the factoring can work. So you have a sine x, and then you have a sine 2x, then you have a sine 3x, and you have a sine 4x. Something tells me that the best factoring to do is to combine this first sine and this last sine, then do these two together, because if you add 1 and 4, you get 5, and you add 2 and 3, you still get 5. So maybe something can happen, and then we're going to use the sum to product formula, because we're trying to find it. For you to get the sign, you must express as a product. So how do you get the sum to product formula? Well, you know that sine of a plus b is equals to sine of a cosine b, and then plus sine of b cosine a. Yeah, that one is known. And then the second part, you know that sine of a minus b is equals to sine A. Why is this not as sharp as it used to be? Sine A cos B, then you have a minus sine B cos A. So if you add them up, you will get twice of sine of A, sine of B to be sine of A plus B, and then plus sine of A minus B. I think this is the case whereby if you take A plus B to be capital C, and you take A minus B to be capital D, I think A becomes C plus D over 2. So A becomes C plus D divided by 2, and B becomes, if you do subtraction, B becomes C minus D over 2. C minus D divided by 2. So you have a sine of A plus sine of capital A plus sine, or how do we put sine C plus D plus sine of D is going to equals to twice of sine of C plus D over 2. So C plus D divided by 2 times cosine of C minus D divided by 2. Now you don't really have to always derive this formula, but you sometimes there's no way I will remember this formula, because you are doing different things in your life. You are going to see your friends. You are doing a lot of things in your life, so you can't always remember this formula. But it's good for you to know how to drive them, because if you know how to drive them, anyway they stop you, they'll be like, okay, do this for me real quick. It's okay, let me drive the formula. Of course, nobody will complain if you take 2 minutes to do this. Anybody that complains, it's the problem, because they don't expect you to forget what you're doing with your life and try to know this formula by heart. Of course, you can know them, but it's good for you to know how to arrive at this formula. So having gotten this, we can now combine sine x and sine 4x. So if you do the combination, you would obtain that sine of x and sine of 4x, sine of x and sine of 4x is going to equal twice of sine of, now x plus 4x is 5x over 2, so you have a sine of 5x over 2. What about the case of x minus 4x? So you have sine of C minus D. Sine of C minus D, that is the case of, that is negative, so you have a 1 minus 4x, so x minus 4x, that would be negative 3x divided by 2, so that is going to be sine of negative 3x divided by 2. Yeah, so now what about this case of 2x and 3x? Well, this is going to be sine of 2x, this is going to be C plus D, right? So you have sine of 2x plus 3x, 5, so this is going to be plus twice sine of 5x over 2. What about this case? Well, this is going to be 3 minus 4. So this is going to be equal to 3 minus 4. So you have 3x minus 4x, which is negative x. So this is going to be sine of negative x over 2, right? Yeah, so we have a negative and negative. So this will be absolute value of negative of all of this. So sine of 5x over 2. And then you have sine of 3x over 2. And then you have, okay, no, it's not even sine. This is cosine. What am I doing? The second term should be cosine. So this is cosine of this. Yeah. So this is cosine of this. Let's write it more clearly. So this is going to be twice of sine of 5x over 2, and then cosine of 3x over 2. For cosine, the minus sign does not matter for us, so we just forget about it. Plus twice of sine of 5x over 2, and then you have cosine of x over 2. So now we need to factor out sine of 5x over 2. So you have twice of the sine of 5x divided by 2, and then you multiply this by cosine of 3x over 2, and then plus cosine of x over 2. So it remains to find the addition and subtraction formula for cosine A and then plus cosine B. So let's do what we did here. Let's try our best. So now for cos A plus cos B, this is going to be simple because we know from that cos A, the cosine of A plus B is going to equal cosine A cosine B minus sine A sine B, and also cosine of A minus B is going to equal cosine A cosine B minus plus sine A sine B. So this cancel out when you add up, so you get twice of cosine A cosine B to be equal to cosine of A plus B, and then plus cosine of what? A minus B. Now we can make some substitution by taking C to be A plus B, C to be A plus B, and then take D to be A minus B. So in this case now, A would be half of C minus D, and then also no, A will be C plus half of C plus D, and then B would be half of C minus D. So essentially, if you come back here, you want to add this up, I think you get twice cosine A cosine B, yes. So you will get 2 times the sine of 5x divided by 2, and then you will get, on this part here, you will get twice of the sine. Yes, you get twice of, no, the cosine of A plus B over 2, which is going to be 4x over 2, which is 2x. So let's be sure. Cosine of A plus cosine of B. So that will be C. C plus D over 2 and C minus D over 2. C minus D divided by 2. Yes. So you get, so 3x plus x, that is 4x divided by 2 is going to be 2x. So cosine of 2x times the cosine of C minus D, that is 2x over 2 minus x over 2. That would be cosine of x, so cosine of x. So there is that. So f of x here now would be 4 times the sine of 5x over 2 times what? Cosine of 2x, and then cosine of x. Now the limit of integration is from 0 to pi. Now from 0 to pi, cosine of x is all positive except when x is in the range of pi over 2 to pi. Okay, cosine of x is all positive except when x is between pi over 2 to pi, and there it is negative. Then on that same case, cosine of 2x, we are looking at from 0 to 2 pi. Cosine of 2x is all positive so long as we are moving. So long as we're moving from, this is going to be a long analysis. So long as we are moving from 0 to pi, it's positive when we're moving from 0 to pi. So this is, let me create a table. Cosine of x is positive on what interval? On pi over 2 to pi. So on pi over 2 to pi, and is negative on what interval? From pi, no, what? Cosine of x is positive from 0 to pi over 2 and negative from pi over 2 to pi. So it's positive from 0 to pi over 2. And negative from pi over 2 to pi. What about cosine of 2x? So cosine of 2x. But cosine of 2x is, where is it positive? Cosine of 2x has range from 0 to 2 pi, right? So in this case, it is positive from 0 to pi over 2, negative from pi over 2 to pi, from pi over 2 to 3 pi over 2, and then positive from 3 pi over 2 to pi. So let's call where it is positive or negative. It is positive at this interval from pi over 2, from 0 to pi over 2, and then also from 3 pi over 2 to 2 pi, 3 pi over 2 to 2 pi. And where is it negative? Well, it is negative from pi over 2 to pi, no, from pi over 2 to 3 pi over 2. So that is where it is negative. Now what about the last angle, the last function there that appear? We're looking at sine of 5x over 2. Well, sine of 5x over 2 is positive on what intervals? And what, when is it negative? Well, it is positive. Say, we are looking at from 0 to pi. So 5x over 2, we are looking at from 0 to 5 pi over 2. Which means that we need to, let me see, we need to go through the circle and stop at pi over 2. Okay. Now, on the moving through the circle, where it is positive, on the first turn, it is positive from 0 to pi, and then it is now negative from pi to 2 pi. Negative from pi to 2 pi. Then it will be positive from 2 pi to 5 pi over 2. So I believe we have done our dissection properly. So now we need to look at the case whereby f of x is positive, where it is. Now it is positive when all the three factors, they share the same sign. So that is where it is positive. When they share the same sign, then it is negative on the intervals whereby they don't share the same sign. So where is it positive? Let's start. So we have the integral from 0 to pi of, in the first, for cosine of x, cosine of 2x, cosine of 5x. So you have cosine x, cosine 2x. This is positive on this interval. So let's look at the interval from 0 to pi over 2 before we go to pi over 2 to pi. So from 0 to pi over 2, what is happening? Cosine of x is positive, so this is a positive sign. And then what about cosine 2x is also positive in this case, and also this is positive, and sine of 5x over 2 is also positive on 0 to 2 pi. Yeah, so it's also positive. So we have a 1 from 0 to pi over 2. We have a 1 dx. Then when is it negative? Let's say from pi over 2 to pi, from pi over 2 to pi, what happens there? Well, if this cosine is positive for sure. What about this pi over 2 to pi? Cosine of 2x is going to be negative on that interval too. So you have pi over 2 to pi is cosine of 2x from pi over 2 from 0 to pi over 2 is positive. Then pi over 2 to pi is going to be negative. So this is going to be negative. And what about this case here? From pi over 2 to pi is going to be positive. So this is going to be a minus. So we have a minus the integral from pi over 2 to pi. So what about the other interval of integration? When is it going to be a what about limit we are dealing with? What about 3 pi over 2? From pi to 3 pi over 2. From pi to 3 pi over 2. From pi to 3 pi over 2, what do we get? From pi to 2 pi, this is negative. This part is negative. What about cosine? From pi to 3 pi over 2, cosine is also a negative. So this is also going to be a negative. From pi to 3 pi over 2. Yeah, this is going to be a negative. Why this one is going to be also going to be a negative. So you have a negative on that part too also. Now what about from 3 pi over 2 to 5 pi over 2 to pi? So you have, okay, I see we actually crossed, should I say, we missed something here, because this is 5 pi over 2. If it is mapped to 0 pi, then this interval will be mapped to 0 and 2 pi over 5. So we need to consider 0 to 2 pi over 5, then from 2 pi over 5 to pi over 2. So it will be considering integral from 0 to 2 pi over 5, but that is smallest angle. And in that interval, they are all positive, so we get a 1. Then 2 pi over 5 to 2 pi over 5 to pi over 2 here. What does from 2 pi over 5 to 5 pi over 2, where do we get cosine of s? Cosine becomes 4 pi over 5, so that would be, and then what about cosine becomes cosine of 2 pi over 5 to pi over 2, and then 2 pi. There will be negative, so we have a negative 1 minus the integral from 2 pi over 5 to pi over 2, and then from pi over 2 to 3 pi over 2, we already consider that it will be a plus 1. Okay, from pi over 2 so, and then the last integral is going to be 4 pi over 5 to pi. So we can collect all of these results, but if we do that, I think we get 2 pi over 5 as the final answer. If you check the official solution, that is 2 pi over 5, but essentially everything is solved here because this is going to be 2 pi over 5 minus 2 pi over 5 minus pi over 2, then pi over 2 minus 4 pi over 5, and so on. So if you add all the pi's, you get that. So let's look at problem 10 on our hand here. This one here is going to equal, you factor out e to the x from here, you get the integral from 0 to 1 of 1 minus x, or divided by, you get e to the x, then you get 1 minus e to the x divided by 2, all squared. Of course, everything on that is square root side. Then if you take u to be e to the x, so divided by x over e to the x divided by e to the x. So you have u equal x divided by e to the x. So what about du? Du would be x squared. No, this would be e to the x minus e to the x minus x e to the x, all divided by e to the 2x, multiplied by e to the negative x, so you get 1 minus x over e to the x dx. So this is going to be equals to the integral from 0 to 1 over e of 1 over square root of 1 minus u squared du, and that is going to be just sine inverse of 1 over e. So thank you for watching, and please just subscribe to the channel. Bye and have a nice day.